Howdy, fifth grade. You're probably excited. This probably will be your last math video for this year. So let's do a little test review for tomorrow so that you are prepped and ready to go and finish on a strong note. So I'm going to present my screen and I'm going to go through this pretest for you. I think you will enjoy it. We'll all have a good time and you'll get a good grade. How about that? So let's go. Let's do this. Round $48.91 to the nearest dollar. Well, that should not be too hard for you. You know that it has to fall between $48. Oof, it's kind of ugly there. I'm not used to writing with this again. Maybe make it a little bit bigger. Between $48 and $49. And since this is 91 cents, you know it's way over here when you talk about between dollars. So to the nearest dollar, which is the same as the nearest whole number, it would be $49. $49. I am going to do something. I'm going to make this a little bigger and then make my thing a little smaller here. All right. Number 2 says round 9.671 to the nearest whole number. Remember that if you're doing to the whole number, there'll be no decimal at all. And the only thing you need to focus on is the number that comes after the decimal. And since that is a 5 or greater, you're going to add 1 to the decimal. So the answer for letter A is simply going to be 10. No decimal, no zeros, no nothing. Letter B, we talked about this before. You know that this fraction is more than a half because the top is more than half of the bottom. So same thing here. You're making it a whole number, no fraction. You need to add 1 to the 7, so it becomes an 8. So far, so good. Number 3, arranging those in order from least to greatest. It's probably best to think about these as fractions. Well, decimals probably. This is 0.1, and this is a whole number 2, and 2/3 is 0.6. Or if you think about this, this has to be more than a half. This has to be less than a half. And this is a whole number bigger than either one of them. So from least to greatest, it's going to be 0.1. Then you've got your fraction 2/3. And then you have your whole number 2, which has to be more. Problem number 4. Problem number 4, 2/3 of the 18 cars were new. And I hope that you're continuing to do this here. Anytime you ask for a fraction of a number, I would very much strongly recommend you draw yourself a rectangle and think about cutting that into pieces here. This rectangle stands for all 18 cars. 18 cars, and I want 2/3 of them. Bottom number says how many equal pieces I cut 18 into. If I divide 18 into 3 equal pieces, each one is worth 6. And the top number tells you how many of those 6s you have. You have 2 of them. So the answer is 12 new cars. 12 new cars. Problem number 5, it'd be very much good for you to recopy the line. Got point A, point B, point C, and point D, and label them accordingly. AD is 6.4. A all the way to D, the whole thing is 6.4. AB is 3.9. So from here, maybe I'll change colors so we can, from here to here, that distance is 3.9. The length of BC from here to here is 1.4. The length of CD, we don't know. But we know that if you add these two together, that'll give you the length of AC, and subtract that from 6.4, you're going to get CD. So if I take 3.9, add 1.4 to it, I get 5.3. That's my whole A to C. I just need to subtract that from 6.4. So here's my 6.4. I'm subtracting 5.3. And remember, with decimals, we have to line them up. In my answer, the decimals are going to go here. 6.4 minus 5.3 is 1.1. So CD should be 1.1 centimeters. 1.1 centimeters. And over at the top here, a shoebox has the shape of what geometric solid? That's a pretty easy one. A shoebox would look like this. And that is a rectangular prism. Rectangular prism would be that. Number 7, which of these angles could measure 120 degrees? And we just have to know that 120 degrees is an obtuse angle. It's bigger than 90 degrees. Angle B looks very much like 90 degrees. Angle C, I can't, not on the screen, is an acute angle, so that has to be less than 90 degrees. So your only choice, this is a pretty easy one, is angle A, 120 degrees. Number 8, please make sure, again, adding decimals, you're supposed to line them up. And the only issue here is the number 3 doesn't have a decimal, so you put it at the end of the decimal. So when you add these, it's 4.39. Everything has to line up underneath that. 1.8 and then 3.00. You can add zeros at the end of decimals just to make them kind of all look alike. 9 plus 0 plus 0, 8 plus 3. 4 plus 4 plus 1 is 9. Mr. Hahn gets 9.19. Same thing for problem number 9, except this is a subtraction problem. 9.14 minus 0.8. And again, feel free to add that 0 there. So you have digits lining up with everything here. Decimal goes here in my answer. 0 from 4 is 4. Have to borrow from the 9 to make this an 11. 8 from 11 is 3, and 0 from 8 is 8. 8.34. Halfway home. Let's check out page 2. See what we got here. These are getting awfully exciting. Oh, we got some division, some multiplication, some subtraction. Number 10, again, remember, this is a subtraction problem. You line up the decimals, and 2 doesn't have a decimal. It always goes at the end. So 2 point, you're subtracting 0.8. Now, word of caution, boys and girls, I see some of you do this all the time. With subtraction, you have to do this in the order it's given. I can't put the 0.8 on top. 2 has to go on top. It's the bigger one. You're subtracting 0.8 from it, so it has to look like this. So borrow from the 2, this becomes a 10. 8 from 10 is 2, and notice we lined up the decimal on that line, and then 0 from 1 is 1. 1.2 is your answer. Number 11, we are simply doing a multiplication problem. 309 times 14. 4 times 9 is 36. Carry the 3. 4 times 0 plus 3 is 3, and 4 times 3 is 12. Get to that second number, which is in the tens place, you have to drop the 0 down. 1 times 9, 1 times 0, 1 times 3. Add them all together. Okay. Looks like 4,326. 4,326. Oh, look, you guys are getting into so much stuff here. Now we're subtracting some fractions here. Have to do the parentheses first. 2 and 5, 6. You can write them up and down. Minus 1/6. They have common denominators. So 1/6 from 5/6 is 4/6. And I get 2 and 4/6. Now I have to take that away from 7. So it's 7 minus 2 and 4 6. You could reduce this, but it doesn't matter right now. We'll just reduce it at the end. Remember, when you borrow, which I have to do because I can't take this fraction away from nothing, this becomes a 6. The fraction you make, this has to be equal to 1 because you took 1 away from the 7. And it has to have the same number as the bottom fraction. So this will be 6 6. Pick 6 because that's the bottom. If you did reduce it and there was a 3 on the bottom, then you make it 3/3. Same deal. 4 6 from 6 6 is 2 6. 2 from 6 is 4. And I can't leave that as my answer because 2 6 can be reduced. I can divide both of those by 2. It's 4 1/3. 4 1/3. Problem number 13. Boys and girls, problem number 13. Let's go with a shade of green here. It is 4 8/12 plus 3 6/12. Writing them up and down, they already have common denominators. 8 plus 6 is 14/12, and 3 plus 4 is 7. Now, 14/12 has two problems with it. Number one, it's not reduced, and number two, it's improper. I recommend you reduce it first just to make life easier. Cut them both in half. 14 divided by 2 is 7, and 12 divided by 2 is 6. Now I need to make this number a mixed number and add the whole number to the 7. So I divide 6 into 7, and I get, remember, your remainder you put over that divisor. I get 1 1/6. That 1 has to be put together with this 7 to give me 8 1/6. 8 1/6. Problem number 14 is just a division problem. 40/28 is being divided by this bottom 4. Keep it neat, keep it straight. Everybody will be happy. 4 goes into 4 once. Subtract. You bring down. Now, if I bring something down, if 4 doesn't go into it, I have to put a 0 up there to hold down that place. You could multiply and then subtract again, but you're going to get a 0. And then boom, bring down the next number. Look, I brought another number down. 4 still doesn't go into it, so I have to put another 0 up there. Subtract and bring down my final number. And 4 goes nicely into 28 7 times. So my answer is 1007. Please keep those straight. Keep those zeros where they belong. Problem number 15. Another division problem. 953 divided by 30. 30 does not go into 9, so you shouldn't have a number above the 9, but it does go into 95. And the best way to figure out about how many times is to look at their first digits. How many times will 3 go into 9? Probably 3. 30 times 3 is 90. So that's my number here. I subtract. I get 5 left over, which is good because it's less than 30. How many times does 30 go into 53? Just once. And looks like I have a remainder of 13. 31, remainder 13. Oh, problem 16. Hopefully you remember, and that's something while you study this. How do you divide by fractions? You divide by fractions by flipping the second one and multiplying by it. First one stays the same. It becomes a multiplication problem, and then you flip this one over 2 over 1. And then when you multiply across, you get 2/5. 2/5. 4 more problems here. Let's see what we got. Problem number 17, a multiplication problem. You need to make this a fraction by putting it over 1, so you end up with 3/5 times 10 over 1. You multiply across, it ends up being 30 over 5, and then 5 goes into 36 times. The volume of this rectangular solid, volume is just multiplying the 3 sides together. We call that the length times the width times the height. So volume equals 3 times 2 times 2. So the volume equals 6 times 2, which is 12 inches cubed, which is what you get if you counted all these. You know, here's cube 1, cube 2, cube 3, cube 4, cube 5, cube 6. That gives you this front row of cubes. So there's 6 cubes there, 6 cubes in that row, and then another 6 cubes in a row right behind it, giving you 12 inches cubed. Number 19, draw an equilateral triangle and show its lines of symmetry. Hopefully you study a little bit about your triangle. Equilateral means all the sides are equal. So when you draw this, even though you may not be able to do it really nicely, put little tick marks. That tells me that you meant to draw them equal. Might be nice if you did a ruler. You could get them pretty equal or close anyways. And then the lines of symmetry, that's the ones that you can cut them in half. And we talked about this in class. You can cut an equilateral triangle like this. You can cut it like this. And you could cut it like that. It could fold on itself in those 3 different areas. Those 3 different areas. Number 20, the denominator 11/12 is 12, right? A fraction equal to 2/3. That is also has a denominator of 12. And then subtract that from 11/12. Okay. So I am taking 2/3. Making it so that it has a denominator of 12. To do that, I multiply the bottom by 4. So I multiply the top by 4. So I get 8/12, and I am supposed to subtract that from 11/12. So I have 11/12 on top. I subtract 8/12 from that. That gives me 3/12, and unfortunately that, ladies and gentlemen, is not my answer. You must always look to see if you can reduce. What can I divide those both by? 3. So I end up with 1/4. The answer to problem number 20 should be 1/4. So we are back in business. I'm going to stop presenting. Make sure you take your test note home. Make sure you get it signed. You will be taking the test tomorrow. Thank you, 5th grade.